And thank you for the nice introduction about me. And my name is Dr. Bibal. Presently, I am associated with IIT Kottayam as an assistant professor, selection grade. And I am also the lead for data science and AI research group at IIT Kottayam. And for today's talk, the title is about implications of IoT and AI in technology-assisted environmental applications. So the outline of my presentation spans around giving an overview about IoT and its architecture and the need for building tiny models with respect to IoT devices. And I'll be giving a presentation about 3 different use cases. One is for healthcare sector, and another one is for air quality sector, and another one is for agriculture sector. And so in addition to this, I will be presenting few findings from the research works that has been carried in our own laboratory at IIT Kottayam. So you would have heard about the word IoT from the long back, right? But the term IoT is a buzzword in the industry. That is like once after this COVID-19 pandemic, all the industries have started talking about IoT. So the reason is, so we all are under lockdown, right? So we were unable to access the various devices that were, or equipments that were being held in a remote places. So there arises the need for IoT. And after that, suddenly there is a need for IoT combined with artificial intelligence for different applications. So now it's an era of IoT and AI for different use cases. And regarding this IoT, so I will give a broad overview of what is an IoT. So IoT means it's a kind of different sensors. You can think about sensors, and the sensors are connected together using some network. And the sensors will be having a software module and also communication module. Using that, the sensors will be exchanging data among themselves over the internet. So presently, so the software component, what I have said is about AI-based software component. And so presently, we have a lot of IoT devices everywhere, like devices for monitoring the temperature or devices for monitoring the quality of the air. Recently, in one of the web-based portal, I have seen IoT-based umbrella. So the application of this umbrella is just, it will remind you about whether it will rain today or not, so that you can take your umbrella and you can go out. Okay. So and we have numerous IoT devices for different applications. And one application is about you will be having luxury vehicles. So in luxury vehicles, you have different kinds of sensors. So whenever some malfunctioning happens in the vehicle, so you will get an alert in the dashboard that something has gone wrong. So that kind of sensors will be integrated with IoT devices in the future. And so those data you can access with the help of computer or mobile phones. So that's the real application of IoT. Say for example, if you have an air conditioner sensor at your home, so this air conditioner sensor will match the outside temperature and it will adjust the temperature automatically. Or you can consider your refrigerator. So the inside for monsoon you will have a kind of temperature, for summer you will have a specific temperature. But if you have some IoT devices, what exactly does is it matches the temperature that prevails outside, and it will adjust the temperature inside your refrigerator. Okay, and see, even in the case of vehicles, when the brake fluid goes down, So you'll get notification in your mobile device that your brake fluid has gone down. So accordingly you can make the vehicle ready for operation. So I have given you some overview about what exactly the IoT devices and what is the application of that. And so whatever the devices we are talking about, it contains artificial intelligence component, communication module, and it also deals with sensors. So regarding this AA, you may think what is the need for AA with respect to this IoT component. So one example I would like to tell, you all have refrigerator at home. So at home especially we have this milk and eggs right at home. Always we used to have this components at refrigerator. So at some time when this goods goes beyond a particular limit, like for example earlier you used to purchase 50 eggs and presently the number of eggs is at the refrigerator is 2 or 3. Okay, so the stuffs has been reduced. So at this point you need an alert that the quantity of milk and eggs has gone down. Okay, how we can accomplish this is like, so you will have a computer vision based AA technology to have how many eggs or maximum quantity of milk at your refrigerator. So when the quantity goes down, it matches with the actual level and it will give you an alert. Okay. And the second point is about networks. So when thinking about networks, so people from computer science background will know about it. So we will think we need a large scale network in order to operate the IoT devices. Okay, but that's not true. So even you can perform IoT related operations with small and cheaper network. The only constraint is the efficiency of the particular efficiency should not be dropped. Okay. And the third part is about sensors. Okay, the true essence of IoT is about the effectiveness of the sensors. So sensors means we expect the sensors should sense the environment. Based on the data it has extracted, some decision has to be made. So the decision making component is the AA component. Okay. So once the decision is made, an alert has to be raised. Okay. So that's the crux of this particular technology. And another point is active and passive engagement. And we cannot see any kind of active engagement of sensors in an IoT environment. All the engagements are completely passive in nature. Okay. So and another point is like usage of cloud infrastructure, so that we'll see later in the subsequent slides. And so nowadays the IoT devices are becoming very smaller, cheaper and powerful. So so we expect a small devices should give the services in a fast, in an efficient and in a very scalable manner. We expect the services from the IoT devices. Okay, so now we'll see about an application architecture of IoT devices. So here I have given a very big block diagram, and here there are 4 essential components. One is about the sensors, second one is about the medium, and third one is about the cloud infrastructure, and fourth one is about the data processing component. Okay. So with respect to the sensors, so we know that sensors are sensing devices, and sensors will collect minute by minute data from the environment. So the sensors will be like even a small simple sensor like a temperature monitoring devices, or it can be a very complex device like webcam that monitors the video, or even you can have a bundle of sensors in a single IoT, a single machine, like you have your phone at your hand, right? So in your phone that you will have multiple sensors like GPS devices, accelerometer. Okay, so you can see that multiple sensors are bundled in your phone in order to do different tasks, right? So here it can have multiple sensors. The only duty of sensor is to collect the data from the environment and to push into the cloud environment. Okay, so now the question is about the medium. Okay, the medium is like how the data is pushed into the cloud environment. It can be a Wi-Fi network, it can be a Bluetooth, or it can be a wide area network, or it can be a cellular networks, or it can be a satellite networks. But the problem is, each of these networks have their own specifications. Okay, that is like it ranges from power, range, and bandwidth. So based on the nature of your application, you have to choose the appropriate media based on the nature of the application. And the third aspect is cloud infrastructure. I don't know what kind of knowledge you have about cloud infrastructure, but I'll give you an overview about it. So cloud infrastructure means we have group of hardware devices, especially computing servers and storage devices. Okay, so in the computing servers, hypervisors will be installed. Okay, hypervisor is similar to an operating system. So what this hypervisor does is it partitions the memory into different partitions, which we call it as a virtual machine. So the virtual machine, it looks like a normal physical computer that you use in your day-to-day life. Okay, so that's the advantage of this cloud infrastructure. So the sensors collect the data, push the data into cloud infrastructure through any one of the communication medium, and at the end the data go for processing. Okay, now comes to the question, like if it is like a simple operation or it's like a complex operation. So the data that is accumulated in the cloud infrastructure may be structured data, unstructured data, or semi-structured data. I'll give you an example about structured data. So structured data means data arranged in the table and rows and column format. That is like your table. Okay. And second is unstructured data, means it's an image or video data. And third one is semi-structured data, means like it's like your text data. Okay, normal Word document or some files like that. Okay. So based on the nature of data, you should have different mechanisms to do the manipulations. Okay. And another point is volume, velocity, and veracity of the data. Volume means the size of the data. Velocity means the speed at which the data reaches your cloud devices. And third one is veracity. Okay, veracity means the type of the data. So these are very important in your big data analytics. That's a very big domain. I'm not going into that. Okay. So now come to the IoT architecture. So as I said, you have seen that small batch size data that has been processed with the help of IoT devices. But the present environment, okay, we don't have that small batch size data. So whatever the data we have, so in each and every fraction of second you will get data. Okay, so that is in a very high speed you will be receiving the data. Okay, that's what we call it as the real-time data, or we call it as the streaming data. For example, if you deploy a sensor in the ocean environment, so each and every minute the ocean temperature will be monitored and it will be transferred to your cloud. Okay, so for each and every minute the data will be recorded and it is pushed to your cloud environment. So here you cannot use a normal tool to process those real-time data. So we need sophisticated tools in order to process these kind of data. So let me give you an insight about that. So from the IoT devices, their data is collected, and whatever the data, it is being pushed into the memory. Okay, so from there, so based on the nature of your requirement, if you want to do some batch processing tasks, we can go ahead with Hadoop ecosystem, or you can use Spark ecosystem. So both Hadoop and Spark are distributed processing ecosystem that can process batch data. Batch means static data. Okay, and in case if you want to process real-time data. Okay, if you want to process real-time data, you have to go ahead with Apache Kafka. Okay, that is a sophisticated tool for processing the real-time data. And so if you want to process, see if you have this SQL databases, that is like that can process data that is stored in the table format. Okay, so if you want to process some unstructured data that is like normal document or document or something like that, you have to go ahead with a MongoDB. That is the most sophisticated tool for processing the unstructured data. Okay, so you can use any of the tools. So whatever the data comes in, you have to apply some filtering mechanisms, filtering or windowing mechanisms. Filtering mechanisms means, say for example, if 1000 data points come at a particular minute, okay, you cannot process all the 1000 data at the minute. What you can do is, either you can filter randomly some instances from the 1000 data points and you can process that. Or else what you can do is, you can extract the latest 10 or latest 100. Okay, that is like you can apply a windowing mechanism. Initially the window will be in the first position. So as the data comes on, the window will be moving from the second, third and till the last position. Okay, so you can use some filtering mechanisms or windowing mechanisms in order to extract the fast incoming data, and you can transfer the data to either it is a Spark environment or Hadoop environment or maybe Kafka, and you can do your processing. Okay. So now coming to IoT with machine learning. Okay. So till now I was speaking about that IoT devices and IoT applications, how they are being processed into it. Okay. See, in IoT environment, assume you have an AC sensor that is being deployed in your home. Okay, so how the communication happens is like the AC sensor is connected to cloud environment with the help of gateways. So, so the person who want to retrieve the data, okay, the persons who want to retrieve the data, they will send a request to cloud environment. So the cloud how the process is done is through RESTful services. So when the person gives an request that I want to access the temperature data, the cloud infrastructure will ask for an authentication. They will ask you to give your username and password. Okay. So once it is authenticated, you can read the particular data. Okay. And another point is like whenever if you want to read some data, it's fine. You can read temperature data or whatever may be. Okay. But the point is like assume video is being pushed into the cloud infrastructure. Okay. And if you want to extract some intruders from the video, okay, in that case, how to apply AI-based tools in order to recognize the intruders in the video, and based on the recognized nature, it has to be, an alert has to be raised to the concerned authorities, maybe to the police or maybe to the house owner, maybe. Okay. So I am going to go very deep into the AI component of the IoT module. So this, you know that why artificial intelligence is required in IoT. Okay. So before that, I would like to tell that the need for data analytics with respect to IoT module. That is like when you get some data, different kinds of analytics has to be carried out with respect to data we have in our hand. Okay. So different kind of analytics means descriptive analytics, diagnostic analytics, predictive analytics and prescriptive analytics. So descriptive analytics means, for example, if you have a data, assume I am having a air quality data, okay, or I am having a weather data. So if I apply descriptive analytics means I will find out what has happened in the past with respect to historical data. Okay, when there is a highest rainfall, or why there is when there is highest rainfall, or when there is the maximum air quality has been degraded. Okay, so that kind of analytics task we call it as the descriptive analytics. The second kind is diagnostic analytics. So diagnostic analytics means, so I have the air quality data. I identified on a particular data the air quality is very low. Okay, so diagnostic analytics means I am able to find out what is the root cause for the particular happening. So if the air quality is low, why the air quality is low? Okay, so if there is a particular disease, okay, for example, a person got heart attack. Okay, so why he got heart attack? Okay, so that we call it as a diagnostic analytics. Okay, so descriptive analytics means we'll find out what happened in the past. Diagnostic means we'll find out the root cause of the particular problem. Okay, and next one is predictive analytics. So predictive analytics, from the past data we will predict what will happen in the future. Okay, the last one is prescriptive analytics. Okay, so if my system predicts that a particular person will get cardiac arrest in future, okay, and prescriptive analytics means it will recommend you the possible solutions in order to avoid cardiac arrest. Okay, that we call it as the prescriptive analytics. Okay, so any kind of IoT devices, we need some kind of data analytics to be done with respect to the data we have. Okay, it may comes under any one of the wings of this diagnostic, descriptive, prescriptive or predictive analytics. Okay, so based on the nature of your problem, you can do any of these tasks. Okay, so how such kind of analytics can be done is by using machine learning methods. Okay, so machine learning is a subset of artificial intelligence. So in case of machine learning, we have two different techniques. One is classical machine learning methods. Second one is deep learning techniques. Okay, so they have their own positive points as well as negative points. I'll tell you in the future subsequent slides. So here in the particular architecture, you can see that the IoT devices will extract some data. Okay, the IoT devices will extract some data from the environment. So here this data will be pre-processed. Okay, so pre-processing means removal of error from the data. Okay, that is, in some cases some error or noise will exist in the data. Can you please keep quiet? Some kind of error will be present in the data. Okay, so that may be like based on sensor errors. Okay, for example, the particular temperature is 98 degree. So if the sensor records that it is 150 degree. Okay, so you will come to know that nobody will have a fever of about 150 degree, right? So at least it has gone beyond the limit. Okay, so such kind of errors has to be identified and cleared. Okay, so in case of image data, some kind of distortions will happen in the image. Like if you take a photograph, you can see that the snaps will be blurry, or some kind of salt and pepper noise will be there. Okay, so those kind of errors will happen in the image data. Okay, both text data as well as image data will have different kind of noise associated with it. Okay, so when the data is collected from the media, data has to be cleaned. That is, error has to be removed. In case of images, the particular noise has to be removed from the image. Okay, then we'll use machine learning or deep learning models to learn the particular data. Okay, so once the machine learning model starts reading a data, okay, starts learning the data, it will generate you a model. Okay, it will generate your model. The model we call it as hypothesis or generalized function. Okay, so to this model, if you feed some unknown data, it will give you some kind of predictions. Okay, so So it's like a equation. Okay, for example, I'll give you a simple vivid example. See, I am having data, that is x and y data. Okay, I am having a equation of linear regression. What is the equation of linear regression? Like straight line equation, y is equal to mx plus c. Okay, so when I apply this equation over a particular data, you will get a new equation like 4y is equal to 3x plus 2. Okay, so how you are getting this particular new equation? The original straight line equation y equal to mx plus c, you are applying this over a particular set of data. Okay, as a result you are getting a new equation, that is something like 4y is equal to 3x plus 2. Okay, so to this new equation, if I feed the value of 3, what you will get? If I feed the value of x, okay, x is 3, okay, 4y is equal to 3x plus 2. And to this new equation, I am feeding x is 3, okay, what you will get? You will predict the value of y, right? So similarly, you will have a data, okay, so to this data you will apply some learning algorithm. So the learning algorithm will generate some model, okay. So if we can call it as a function, or we can call it as a hypothesis, okay. So to this hypothesis, if you feed some unknown values, okay, you can make some prediction, okay. So that is the analogy behind the working of the machine learning model, okay. So whatever the data that has been collected from the IoT devices or fed to machine learning or clean fed to machine learning model, as a result hypothesis has been generated. Using this hypothesis, we can deploy the hypothesis in a real environment. Okay, I can give you an example. I am having images of certain animals, say for example dogs and cats. Okay, so I am training, I am applying a machine learning model over the image of dogs and cats. Okay, as a result, I am getting a model. So this model can be deployed in the public places to recognize whether there is an animal like dogs or cat. Okay, so there are some significant problems. See, if I am training my models over black dogs and black cats. Okay, so when I am deploying this particular model in a real environment, the real environment is subjected to various problems like illumination and other stuff. Okay. So another thing is, in the real environment we will have colored animals, right? Colored dogs or colored cats, whatever may be. So how we can solve this particular problem is, like, you can apply a method of called as batch normalization. Okay. So whatever the problem that exists within the training environment and whatever the problem that exists in the real environment can be compensated with certain associated technologies. Okay. So when you research more into that, you can learn about it. Okay. And here you can see that the IoT devices has collected the data. It has been cleaned, pre-processed, and model has been built, and it has been deployed in a particular environment, and you can retrieve data about various instances. Whatever you want, you can retrieve it from there. Okay. So now you understood about what is machine learning model. And now the point is, like I said, IoT devices are very small devices. Presently the IoT devices are very small and they have resource constraints, that is the memory will be very small, right? So in that case, if I am building a very big hypothesis, okay, if I am building a very big function, complex function, how can I accommodate that function into the IoT devices that are resource constrained? So if I want to deploy a very big function into a memory of devices, accordingly the system should have sufficient memory, right? So in case the IoT devices will have very limited memory, then how will you deploy the particular model into the devices? That is a very big question. Okay. So now come to the point of, like we call it as the tiny machine learning models. Okay. So for other applications we use machine learning models, but in case of IoT devices the focus is towards tiny machine learning models. Okay. So my present research is aligned towards building of tiny machine learning models for societal applications. Okay. So I am concentrating on different research areas. So I would like to give my findings over 3 different use cases. Okay. So one is about IoT in healthcare. So you know that presently you all will be having smart watches, right? So these wearable devices are associated with the IoT, and for IoT devices has enhanced the healthcare sector.